Hello dear friends, welcome back tutorial from the NX. Today we will see the CAM operation, computer-aided manufacturing, and today we will see the how to obtain the pocket milling with the floor and wall IPW method, and as well as we will see that today how to create the drill cycle and create the holes, and in this case we will use the we will learn how to obtain the hole recognition. That means that automatically that recognize the hole features like this. Here you see the several holes is given in the product, and we will learn obtain this pocket and the how to recognize these several holes in our the model. So this is our the modeling environment. So let's for the beginning go further to the manufacturing environment. In order to do this, to go to here the application and select from the toolbar this manufacturing. So you will be directed to the manufacturing environment. So we obtained opened the manufacturing environment. As usual, for the beginning, we have to specify the 0 point of the workpiece, the blank of the workpiece, and the workpiece itself. In order to do this, go here from the toolbar. Here the machine, the here go here the geometry view, and here for the beginning, let's double click the here the to define the machine 0 point, and you can as usual define the machine 0 point to the any point by the clicking of the mouse here to this point or this point, and maybe you can put the center of the workpiece. Now in this case, in this practice, I will put here in the corner here, and here you see it is representing x, y, and z coordinates, and it is the reference point, and it is the color as we discussed. It is the 0 point of the workpiece. So it is the you can press OK here. So it is defined. Now it's just next step is to define the workpiece to be the manufactured, and it is the blank geometry. So in order to do this, go here to the workpiece and double click here, and here to specify the part, select this icon, and select the workpiece on the screen, and you see it is selected the item 1 and press OK. So the workpiece is selected. Now it's specify the blank. So in order to do this, go here to this icon, and here the type, let's select the boundary block, and you see the workpiece, the boundary geometry is representing with the x, y, and z positive and negative directions. That by default the values is the 0 in all the dimensions. So in this case, let's keep all the these 0. So we don't need the just the overstock. So we will keep the blank their geometry the same as our the workpiece. So let's keep all the values 0 in our the cases, and just press OK. And here we can see by the click the display toward the workpiece, and click into this one. We can see the work part is the blank is obtained. So we defined our the first setting parameters of our the operation. Let's press OK here. Now for the next operation is the creating tool for our the pocket milling, for the creating for this pocket. The tool we will use the end mill with the flat. So in order to do this, let's go here the create the tool. The select from the type the mill planner that by default it's selected, and as usual we have the two options to create the tool. We can create the manually, or we can create the retrieve the tool from the library here. In this case, let's create the tool manually. Then we will create here the end mill. The first one is selected, and here you can define the name of the tool here. Let's call it end mill. And let's direct write the diameter. Let's make it a diameter of the 6. So, and let's press OK here. And you see the tool is illustrated here, and we can change here the diameter to the 6 millimeter. So this tool is used in order to obtain this pocket. Now it's okay. We can define as usual here the material of the tool. By default, this is the high speed steel. Then if you have the several tools in your the machine, you can define here the numbering of the tool. Let's make the numbering of this tool is the 1. It means that this is the tool number 1. And here by the looking for these parameters, you can define the parameters of the tool, the fluid length, the total length, some the tip angles and the taper angles, lower radius, and so on. By default, I will keep all the values like this one, but you can define by yourself looking at the tool specifications. So, and here you can see our tool on the upper position. So the same way you can create the shank for the tool, like activating this one. You can make the holder and so on. And now let's go here and just press OK and go here to machine tool view, and you see our tool is created in the list of the machine tool view. So the tool numbers the one with the diameter of the 6 millimeter. Now is the next step is to create the operation. So in order to do this, go to the here the create operation. From the type the will in the mill planner, and here we have select to the next option is the floor and ball with IPV. So today we will see that this one. So how to create the pocket using the IPV option. Then the previous lesson we have seen the just the symbol, the single, the floor and ball. Now we will see the with the IPV level. So select this one. In the case of the location, just to go here, the program located in the inside of the program. The tool is to select the tool which we created, the end mill with the diameter 6 millimeter. In the geometry, select the workpiece. It means that the system automatically recognizes the workpiece and the blank geometry, and you can define the method as you want. That for you can make roughing operation, semi-finished, and finishing. In the roughing and semi-finish operation, the material will be the remainder after the operation, and we have to make some finishing operation as well. But if you want to directly finishing operation without any the material removal after the operation, you can select the finish in my cases, and here the name of the operation is by default is the wall and IPV floor. So press OK. So you will be directed to the menu of the floor and wall IPV the operation. And here the most important things is you have to specify the cut area. Here the part is the already automatically defined. You see here you can see here because here the in the geometry is a selected workpiece. But the important is now is to select the cut area, so it is not defined yet. So you have to manually insert the cut area of the floor for this operation and select this one to specify the floor area. In this case, the floor area is the cut area is this face, so it is selected. You see the since it is a single face, and press OK. Now we can see the cut area by this icon display. You see the cut area is here displayed. So in the next step is to define the tool. The tool is to define it because we already inserted in the main setting of the our operation. And the tool axis you have to specify this along the Z positive axis. So you can close it. The now is setting the pass setting. So our operation is the finishing operation. So we defined it, and here the cut pattern. Then for the pocket, mostly used is the follow part or follow periphery. You can define the as you want. Now let's select the follow part, so we can see the later with the next option also. And here what is the important is the here you have to define the cutting the depth per cut. By default it is 0. By default it is 0. You can define the cut the depth per cut. The difference between the floor the wall IPV and just with the floor wall. In the floor wall, if you remember, we have the indicated our the blank distance. So in this case, we are not. It is not necessary to indicate the floor distance. I mean the blank distance. So it is automatically recognized, but it is necessary to indicate the depth per cut. So let's for the beginning define the measure the blank distance. Go to the analysis, select the measure the distance, and the distance. Let's select this surface and this surface. So it is the 3 millimeter. You see the 3 millimeter. So the system in this case with IPV floor wall IPV recognize it is the 3 millimeter automatically. Then why it is not necessary to indicate here the blank distance, but you have to indicate the depth per cut. Let's make it 1. So it means that every 1 millimeter will be the cut. You see here, that's why here we have the 3 layers: the first layer, second layer, and third layer. If you make here, for example, 0.5, it will increase the values. You see, every layer becomes to 0.5, 0.5, 0.5, and 0.5. And if you divide 3 to the 0.5, it will be the sixth layer, first layer, second, the third, fourth, fifth, and sixth layer. So it represents the layer. So if you want to make the accurate operation, then the 0.5 is okay, and it depends on your the tool specification, because in the tool specification it will be given the maximum available the cutting depth of the tool. So you can define this value according to the tool specification. So let's keep it to 0.5 for our the cases to make the accurate operation. Now here as usual for the cutting parameters, you can keep the cutting parameters as default in the pocket milling, because it gives us the optimal solutions. For example, for the cut direction, you can define the clean cut or conventional cut. It is the difference is that in the clean cut that the feed rate is the opposite to the opposite to the movement of opposite to the rotation of the tool. In the conventional cut, you see the feed and the rotational is in the same direction. So you can define the as you want. And here the stock value that you have to keep here the 0, since that is the means that we are not remaining material after the operation. And in the corners, and you can define the corners here, the all passes and so on, and the connections, that is the and the connections. So let's keep the all list here, that's by default, and so on. Just press OK. And also for the non-cutting parameters, non-cutting movement parameters, we will keep the as default, which the system, the software give us here, like the engagement movement, retracted movement, rapid movement, and so on. So press OK. And we can define as usual the feed rate and speed by ourselves. And basically the spindle speed will be the given, so it is the related to the tool specification. So let's keep it to 1000 and just press here the calculate these two the surface speed and feed per tool. So just press OK. So we defined our the settings like the cutting parameters, non-cutting, and the feed weights, and now we have the generate our the toolpath by clicking the generate the icon. So the toolpath is created here. So with the depth cut is 0.5, you can see here, and we can verify our the toolpath by the clicking this icon, verify it, and go here to select as a dynamic. Then the speed you can make it 5 here, and just play it to see the simulation of the pocket milling with the IPV. So when you have the pocket, you can use the both one. So both floor and IPV. Here we use it, but in the previous lessons we used also the here the this method. So it is not the difference. The just difference is only the in the floor wall you have to specify the blank distance, but in the IPV it automatically recognize the floor, I mean the blank distance, but you have to indicate here the depth cut, the depth per cut. So this is just the difference between the two operations. So now we have finished our the operation with the pocket milling. Now is the next step is to making the drilling cycle for these holes. So here the let's for the beginning this time the measure the diameter of the holes. So go here the analysis, select from the measure and diameter, and select for example this one is the diameter is 20 millimeter. So you can create the drill cycle, yeah, like here go here the home the create operation, and here the go here the hole making, and you can create here the by the drilling operation which we have seen in the previous lesson. But now we will see the how to generate the drill cycle, that is the automatic drill cycle with the hole recognition. In order to do this, go here to the machine feature navigator here in the left side. So machine feature navigator is selected, and right click here to bring your mouse here, and right click here and go here just here the select the find the futures, the find the future. So we will automatically find our the futures here, and select here from the list. From the list we have to select here the futures. So from this list, from the futures, here you see the several the futures that you can filter from the list to define the which kind of features do you want to recognize. You can, for example, counter bore hole, the countersunk hole, and so on. In this case, our hole is just the single hole. You can here define the slots and so on. So our hole is a step hole, so it is the selected here. You should select here, and it is not straight, so you can here the select for example the all one, so step by step, but in this case for us it's not necessary. We are only going to recognize the whole is the step hole, so that's why it is the here the only one is the selected here the step hole. Let me show it again. Here the step hole is select. So now it's just here the go here to find the futures icon, and define the press it find the future. So the system will look for the futures for our the specification, the step hole, and close this icon, and you see the here in the list the hole is this all the holes is the selected, it's the find it. In addition here the some features is selected that find it, but for us it's not necessary. Now let's press OK to see our the features. You see here the features is selected, but here the surfaces is also automatically selected, but we can delete all of them. Here the only the keeping the holes and selected here the surfaces. This one, this one, this one, and this one, and right click and delete it and delete. Only the remain the holes. This one you see the holes only the recognize it. So here to here, here, you see all the holes is recognized. Now, and right click here, so we defined our the holes. So the holes is the 11. So this is the 11. All the holes is 11. Now select these holes. So all the holes, select all the holes and right click here and here go here the create future process in order to automatically define the process for this operation. And here the we can define here the drilling operation is activated for this operation, and here the two operation, this is spot drill and the twist drill. So firstly this hole is obtained by the spot drill and the twist, and then is the after then it is the then drill it, after then it's drill. Just press OK here to obtain the operation for this 11 holes. It is automatically generating the operation. So you see the operation is automatically generated. Now go here to the operation navigator and go here to the program order, and you see here the this one is the which we created before, and now we created here the automatical this spot drill and the drilling operation. In order to activate this operation, open this one and double click to the spot drill and just generate it. So you see the spot drill is generated. We can verify it that the spot drill. In this case, you see the system automatically defines the tool itself and also automatically defines it is the operations on all the parameters. Let's play it. So to see, you see it is just a spot drilling. It is the initial the spot drilling. Let's restart it. See in the lower cases. So you see it is just a spot drilling, so we activated it here. Now let's see the open this one, and in this case we have the automatically generated three operations. This one is the drilling with the lower diameter with the half diameter, and the second one is with the higher diameter. So in order to activate, let's activate here, double click here and just generate it. So the first operation is activated, so we can verify it here. Just play it. This is the just the half diameter is the obtained of the hole with the 10 mm diameter. Press OK. Here all the systems here will be automatically obtained by the feature recognition which we did in advance. So press OK. Now the last step is to activate it here. So regenerate it here and let's verify it. So this is the how to recognize the such a system. In a system such a host, you can use the more efficient way. So in this case, you see in the program order, here program order, we have this one, the floor, and we have the spot drill, and here we have in the drilling we have to operations. So with the 10 millimeter diameter first one, and is a last is a 20 millimeter diameter, as well as if you go here the machine tool view, you see here the tools also the generated automatically for the drilling operation. This one is for the spot drilling, and this one is for the for the uh, 10 millimeter drilling and 20 millimeter drilling. So this is the how is automatically you can make this the operation with the holes. In the next lesson we will see also how to automatically generate the tool and tool path for the other features like the pockets and so on. So this is all for today. Thank you for the attendance for the lectures. See you on the next our tutorials.